Do you remember doing substitution or elimination at some point in your life? Okay, that's what we're doing today. Substitution, elimination. So, remember to do substitution. Easy to do substitution when you have like y equals or x equals, where you already have one of the equations solved for one of the variables. Substitution, you take what y equals and you replace it with y in the other equation. We're substituting these two because they're equivalent. And I get 7 minus x equals negative 3/2 x plus 6. So I just use substitution to create an equation that only has x's in it. So what am I going to do? Solve for x, right? I'm not going to start with 7. Actually, I don't like fractions as much as I teach them. I don't like fractions. So what I would do before moving anything around, there's a rule in math that says if they're equivalent, as long as you do the same thing to both sides, you can do whatever you want. I can multiply both sides by the same number if I want. I'm going to double both sides. Because when I double both sides, I get 14 minus 2x equals negative 3x plus 12. Now I don't have fractions. That is an optional step that I choose to do because I don't like fractions.
Pardon the interruption. Any student who has makeup exams that has not formed the community room needs to do so at this time. Any student that has makeup exams that has not gotten there needs to do so at this time.
Okay. So now we're going to solve for x. I'm going to add 3x to both sides. You guys might solve in a different order than I do. We know how to solve, right? We know how to solve, right? Right? Okay. So I get x equals negative 2. We are doing the exact same thing that we were doing when we graphed. We are finding where these two intersect. So my answer will be an ordered pair. I know the x value at which they intersect. How do I find the y value? Right. So I'm going to stay organized. I didn't do this earlier, but I left a space. I like to label these equations so when I'm talking to you, you know what equation I'm talking about. When I look at your work, I know what the heck you did. Organized. Excuse me. So what I'm going to do is I'm going to take this x equals negative 2 and I'm going to plug it in to equation 1. And I plug that in. And I hope we do not need our calculator for this. Nine. Did you get the same answer, or did I mess up? I did it right? Yes. Okay, so now I hopefully have the right answer. Is there a chance with all of this solving that you know your teacher might accidentally make a mistake somewhere? There's a slight chance about that. So we do need to check our answers. To check your answer, you can plug both of them back into both equations, but since I just used equation 1 and I already plugged in x and I found y, I'm just going to check in equation 2, and that should be enough checks. Hopefully our math isn't so bad that we may make that many mistakes. So I'm going to check in just equation 2. So y is 9 equals negative 3/2 times negative 2 plus 6. Then I get 9 is 3 plus 6, which is correct. So if I plug in 1 and then I check in 2 and it checks, I should have the correct solution. What is my solution? Negative 2, 9. Ordered pair, negative 2, 9. That's going back to like algebra 1. All right. Question B is also substitution. But this time, like, I would use x equals as what I'm substituting because it's already nicely laid out for me. So if x equals this, I'm going to replace that for x. So what I will have is I will have 3 parentheses negative a half y plus 4. Subtract y equals 2. So I placed just the x with what x equals. And what do we need to do next? Distribute. Negative 3 halves y plus 12 minus y equals 2. What do I need to do next? I can. That's not what I was going to do, but you can here. What should I do? Huh? Why would you multiply each side by 2? Is that a necessary step? No, it's optional, but I would do it. Because that's going to get rid of this fraction. I will now have negative 3y minus 2y equals negative 20. So we're going to combine our like terms. Negative 5y equals negative 20, so y is 4. Yay, I found y. Does it matter? No idea. Does it matter which equation I plug y equals 4 into? Shouldn't matter. So I'm going to plug in to 2 because it looks easier to me. Hold on. Plug in 2. So I'll have x equals negative a half of 4 plus 4. Negative 2 plus 4, so 2. So I got x equals 2. My next step should be to check my x and my y. So if I plugged in 2, which equation do I need to check in? It has to be the other one. You can't check in the one you just plugged it in. You have to plug these values into both equations some point in your work. So 3 times 2 minus 4 equals 2. 6 minus 4 equals 2. Yep, that checks. So my solution, two, 4. Does that bring back good memories? Yes, something easy. All right, and then we have elimination. So elimination is the one where you like add the 2 equations up and cancel something out. You guys remember elimination? So to start elimination, everything has to be lined up, like the x's, the y's, the equal signs, the constants. They all have to be lined up. So I have that. Now if I add these equations, the x's and or y's do not cancel out. So with equation 1 and equation 2, I need to multiply. I need to use the multiplication property of equality. I need to multiply both of the equations or one of the equations to get either my x's or my y's to cancel out. If you look at your x's and you look at your y's, what should we try to cancel out, the x's or y's? There's not a wrong answer. There's one that I think looks easier. What do you guys think? Peter, what'd you think? The x's, because this one's 5, this one's negative 1. So what would I multiply this one by? it's already negative, right? So if I multiply it by just positive 5, I always suggest rewriting both equations, and I know it's like, oh my gosh, that's so much extra work. But I always recommend it because people make mistakes when they don't. And then you come to me and then you say, I can't find my mistake. I'm like, well, because you didn't write out all your work. So now when we add these together, the x's eliminate. And we are left with 7y equals 13. So now I can solve for y. Y is 13/7. Don't turn that into a decimal. Such a lovely number. So now, once we know one of the variables, we're going to follow what we did for the substitution step as well. Once we know one of the variables, we're going to plug it in one of the equations and solve or check in the other equation. Which equation should I plug this one in? I mean, they're both ugly. We can do the second one. So let's plug in 2. And I'm always going to go back to the original. I'm not going to use the changed 2. I'm going to go back to the original. Negative x plus 2 times 13/7 equals 3. When we multiply fractions, we put 2 over 1, multiply straight across. Negative x equals plus 26/7 equals 3. We need to solve for x. What should we do? Subtract 26/7. We can do that. Can we? Can we do that? How am I going to subtract those? Ugh, so much work. 21/7. Oops. I'm just making fun of you guys because this is what you're all thinking in your heads, right? Did I once say pull out your calculator? No, I didn't, did I? Okay. So I've got negative x equals to be negative 5/7. Did I do that right? Negative 5/7? Yeah. And so what's x equal? 5/7. All right, we know x and y, so we're going to check in 1. Got to check in a different one than we plugged in. 5 times 5/7 minus 3 times 13/7 equals negative 2. So this should come out to be a nice number. When you multiply 5 times 5/7, you got to put that 5 over 1, multiply straight across, 25/7 minus 3 over 1, 39/7. 25, take away 39, negative 14/7. Does it check? Yes. So we have an ugly answer. It's not that problem's fault. Can't help that it's ugly. 5/7, 13/7. Are we okay on elimination? Do I need to do a second? This should be stuff that you guys have done a lot. I mean, we are going to do more elimination. We're just going to do it with other equations, so I'd like to move on, if that's okay. Because where it becomes algebra 2 now is when we have nonlinear equations. So if perhaps we were trying to solve the system between a circle and a line that could maybe have 2 answers, between a circle and parabola could have 3 answers. You guys saw this when we did it by graphing. You've seen this already. Ooh, here's a hyperbola and a parabola. Could have 4 solutions. We haven't done hyperbolas yet, but so we're going to do nonlinear systems by substitution or by elimination. When you look at this, your goal is to take this and get it down to just one variable. And when I look at that, I have y, and then we've got x, and we also have x squared. But x and x squared are the same variable, they're just not like terms. So what I want to do is I want to get y out of it. So what I'm going to do is I'm going to solve one of these for y. Which one would you like to solve for y? 1 or 2? 2? Okay. So I'm going to add y and add 1. So my new 2 would be 2x plus 1 equals y. So by substitution, we're going to take 2x plus 1, which is y, and we're going to put it in for y. Sorry. X squared plus 4x minus parenthesis 2x plus 1 equals 7. So I always put parentheses around what I plug in so I don't make any silly mistakes. Questions so far? What should I do next when I go to solve this? Sammy? Distribute that -1 that's out there. So I have x squared plus 4x minus 2x minus 1 equals 7. What should I do next? Prob? Prob? Sure, why not? Why do you want to subtract the 7 and not add the 1? Just curious. Why? Oh, because Katie said so. So then I'm asking Katie, why do you want to subtract the 7? Why do you want to make it equal to 0? Because somebody taught you well. How do you know this is going to happen? Like, what here is telling you I probably want this to say equals 0? Neil, what were you going to say? Right. Because I have an x squared and I have an x, we're going to have to use one of those methods that you learned last year. Could be factoring, could be quadratic formula. Maybe you want to do complete the square, but we're going to have to use stuff that you did last year. I know that we've reviewed solve by factoring this year. Have we reviewed quadratic? We have reviewed quadratic formula also, so we know how to do those. It might take a second to remember them. Okay, so you guys still haven't done what I would have done first. Yeah, combine I would have done that first, but that's okay. We're still going to do it. X squared plus 2x minus 8 equals 0. So fingers crossed this factors. X and x minus plus. Does it factor? Yes. 4 and 2? Good. So I got x equals 2 and x equals -4. How many solutions is this one going to have? 2, because we have 2 x's. So now we're going to stay organized. And where I'm writing my work is not really following order. So I'm going to go over here to find y. Which one would you like to plug in to find y? Which one? Plug in 2? Okay. But I'm doing it for two different ordered pairs, so that's why I have like a little chart. So 2 times 2 minus y equals 1. So 4 minus y equals 1, so y has to be 3. And that's going to give me the ordered pair 2, 3. And then we've got 2 times negative 4, take away y is, oh, I'm sorry, that's not a 1. Hey, stop me. I made a mistake. It's negative 1. Tell me, I made a mistake. So this is not 3. Hey. No, it's not.
Isn't the y negative 0?
Yeah, the y's negative.
And the 1 is negative, so then
So I get 5.
yeah.
I was just actually thinking 4 take away what gives me negative 1. But you can also solve it by moving the 4 over, divided by negative 1. Okay. So this is a negative 1. Last mistake I made, making the whole 2020. I can't even say it without laughing. So if I move my negative 8 over, I get negative y equals, becomes positive 8 over here, 7. So y is 7. Negative 7, I mean. So that would be negative 4, negative 7. Did I do that one right at least? Did I make a mistake on that one? Did I make a mistake? Okay. All right. Now what do we need to do? We just plugged in 2. Check in 1. Okay. So I left my space over here to check. Like everything's not in order here. Sorry, guys. Check in 1. I'm going to check both of them. So x for the first one, 2, 5. I'm going to do 2 squared plus 4 times 2 minus 5 has to equal 7. I did not leave myself a lot of space. 4 plus 8 minus 5. 12 minus 5, yep, that works. Good. The other order pair I'm checking is negative 4, negative 7. So if I do negative 4 squared, that's 16 minus 4 times negative 4 is negative 16 minus negative 7, so plus 7 has to equal 7. Yeah. Nope, I did something wrong. This is a plus. That's what I did wrong. Okay, so 0 plus 7 equals 7. Yep, that checks. So we've got 2 solutions. They both work. 2, 5, negative 4, negative 7. Do you know that there is studies done that show when your professor goes fast and you don't have enough time to write every single little detail down, you train yourself to write down the most important stuff and you actually learn it better? Look it up. There's studies that do that. But it makes you like learn it better. Plus, I'm recording a video right now, so if you really want every tiny little detail written down, you can just go back and rewatch those little places that you didn't quite finish. We won't see, well, I guess we'll see each other tomorrow, but after XH tomorrow. Okay, so that was fun. The next one, these are all by substitution. I'm going to skip B. Let's go to C. I think this one's a lot like A. Let's go to C. That way you have all that space. We're going to do substitution. Which variable should we make x equals y equals? Which one should we substitute? Okay. When I look at this one up here, you have x squared and x, you have y squared and y. It's not really going to make it easier for you to solve for x or for y. So for this, one way is not easier than the other. So solving for x is totally fine. And we're going to do by substitution. So every place that you see an x up here, you're going to plug in y plus 2. How about I do that up here since I have all this space now? I'm going to have y plus 2 squared plus y squared minus 4 times y plus 2 minus 4y equals negative 4. It's all y's, so we can solve for y. How do I multiply y plus 2 squared out? Yeah, you're going to write it twice and you're going to FOIL it, which is y squared plus 4y plus 4 plus y squared. I'm going to distribute the negative 4. Negative 4y minus 8 minus 4y equals negative 4. Collect some like terms. Like terms, do we have any here? 2y squareds. I use those. Ooh, those cancel. But there's another negative 4y in there. Use that. And I've got a 4 minus 8. Actually, if I went ahead and added the 8 to the other side, not 8, I'm sorry, 4. I was thinking in my head what the answer will be. If I added the 4 to the other side, I would have 8 minus 8, which cancels out. So that's what I would have. Ooh, that's a lot nicer looking. So we have a squared in it, we have a y in it. How are we going to solve this? They didn't. They added together. I put a line through them when I use them, so I don't accidentally miss something. Peter? I'm going to factor it by finding the greatest common factor, yeah. So I'll have 2y times y minus 2. And now it's factored, so we set each factor equal to 0, stuff that we've practiced this year already. I get y equals 0 and y equals 2. So what would we do next? Plug it in. Which equation would you plug in? Yeah, I would plug in 2. And you got to do both y's, and then I would check in. I'm not going to finish this one. Check in 1, and you got to do both to know that you're doing it right. If something doesn't check, what does that tell you? It tells you you made a mistake. It does not say there's no solution. If something doesn't check, you made a mistake. Okay? That's why we check, to find our mistakes. I'm not going to finish this one. Just want to make sure that we get to, and we're not going to do solve using a graphing calculator. If you want to solve using a graphing calculator for now, I would just type it in Desmos. We're not going to do this one today because of time. I will show you how to type that into your graphing calculator on block day, okay? So we'll just do block day for this. If I mentioned this for like a half a second yesterday. If there is no solution, you might have a situation where you have like parallel lines. If you go to solve it, I want to show you what happens so you know that there's no solution. If it doesn't check, you have the wrong solution. But if there's no solution, look what happens when I go to solve this. I'm going to look at this and I'm going to say I probably could do this by elimination. I'm going to multiply the top equation by negative 2. Negative 4x plus 6y equals negative 10, and then I got 4x minus 6y equals 1. And I eliminate my x's, however my y's also eliminated, and I get 0 equals negative 9. Is to solve for a variable, but I don't have a variable to solve for. So if you lose your variable entirely and what's left is not true, then it's no solution. Meaning on the graph they would not cross. That's when you'd have no solution, if you lose your variable entirely. This third example would be if you have two and they're the exact same equation, but let's say you're not graphing it and you don't realize that. I'll show you what it looks like if you were to solve it. For this one, I'm going to multiply by -2. So I have -4x plus 2y equals 2, and then 4x minus 2y is -2. And I add these up, and everything eliminates, and I get 0 equals 0. So now I cannot store a variable. However, this is true. So that tells me that they are the same equation, and we would have infinitely many solutions. Yes? Yeah.
It's like, it would be like 10 equals 10.
That would be the same thing. I just can't think of many times it would be 10 equals 10, but it could happen probably. Oh, and that's our notes for today. So the assignment is written on Canvas. It is in the book. The book is linked to Canvas as well. So if you didn't check out a book, you can just get on Canvas for the book. It's on the calendar for today where you guys downloaded. Yes.
Do you want us to print some?
I want it on paper because if you don't print it out, I'm going to have to, and that took like a bunch of extra time. Someday, I'm going to figure out how I can organize so you guys could just send me your answers and we don't have to do the whole printing out thing, or just do it on paper. Some of you want to do it on paper anyway. This is for accuracy. Yeah. Here it is. Here it is. It is for 2 different pages in the book, because I think they have, I can't remember if they have linear and nonlinear on 2 different pages, or if they have elimination and substitution on 2 different pages. I can't remember how it's divided up right now, but that's why it's for 2 different pages. Okay? Yeah, Neil. A lot of it is going to be accuracy. I won't say 100%. I'll tell you, any reviews that we do, I'm still going to post answer keys for all reviews right before test and a quiz. Where is that?